In this video, we're going to talk about the average rate of change and the difference quotient. So first off, the question is, what determines how much a line is going to increase or decrease? Well, the answer to that question is slope. Okay? So the average rate of change talks about the slope of the secant line containing 2 points that lie on the function on a specific interval. So I've drawn a quadratic function, and the red is a secant line that touches the graph at exactly 2 different spots at x1 and x2. Okay? Now, how do you find the slope of a line? Well, it's what? Change in y over the change in x, or rise over run. Well, in this case, that's what? F of x2 minus f of x1 divided by x2 minus x1. That is how you determine the average rate of change. So let's write it down here. Given 2 points, the average rate of change formula is slope, which again is f of x2 minus f of x1 divided by x2 minus x1. Again, same thing as delta y over delta x. Now, let's calculate the average rate of change of this function from 3 to 5. So, first of all, I need to be able to determine what f of 3 and f of 5 are. Well, let's start with f of 3. 3 squared is 9. 3 times 3 is 9, so 9 minus 9 is 0. F of 5. 5 squared is 25. 3 times 5 is 15. So 25 minus 15 is 10. So my average rate of change is equal to f of x2 minus f of x1 divided by x2 minus x1. Well, I'm going to do it 10 minus 0 divided by 5 minus 3, which is 10 over 2, which is 5. So the slope of that secant line is 5. Or in other words, on average, in that interval, the slope is positive, meaning it's going to go up to 5 and to the right 1 on average. Not all the time, because we're not dealing with a line. Now, I have this graph on Desmos. Now, if you take a look from 3 to 5, you can tell that the slope for this is positive. From left to right, it is going up. So I would expect my average rate of change to be positive. Okay, so now let's do the other example for this. This time around, I'm going to go from -2 to -1. Okay? Let's see if the average rate of change is the same from our previous answer. Well, we need to be able to determine what f of -2 is going to be and f of -1. So let's do -2. So -2 squared, that's 4. -2 times -3 is a positive 6. That's 10. F of -1 is what? 1 plus 3. That's 4. So my average rate of change is f of x2 minus f of x1 divided by x2 minus x1. So 4 minus 10 divided by -1 minus a -2. So that's -6 over 1, and that's -6. So notice the same function, but the interval is different. Notice my average rate of change is not the same. Keep in mind, we are not dealing with a line. So let's show the Desmos for this. From -1 to -2, you can tell the slope is decreasing, or is negative here. So you would expect your average rate of change to be negative also. Okay. Now, let's talk about the difference quotient. So, I have drawn a similar quadratic function and a red secant line that passes through these 2 points. Now, what I have done is written out that the distance between the 2 points on the x-axis, that is a distance of h. So the first point from 0 to x is just x, and we'll call it f of x as the range value. The other value for this, which is here, okay, we are going to have that be x plus this distance of h, which is x plus h. So its range value is going to be f of x plus h. Now, we can determine what the difference quotient is going to be, again, or the slope for this, right? So let's call this m equal to, again, change in y over change in x, or rise over run. That's f of x plus h minus f of x divided by x plus h minus x. Now, notice in your denominator, I can subtract out the x's. Okay. This is my difference quotient. Okay. So the difference quotient formula, I'm just going to rewrite. Again, it's nothing more than the slope of the secant line is f of x plus h minus f of x all over h. And again, the difference quotient is another form of the average rate of change. All right, so let's determine the average rate of change for the given function. Now, notice this is a linear function. Now, again, really, what is it asking me for? It's slope. You already know what the slope is, right? Because you should already know what this answer is going to be, but I'm going to use the difference quotient for it. Now, in order for me to use the difference quotient, I need to be able to determine f of x plus h. So let's do this on the side. F of x plus h, and that equals, well, that's 3. Now remember, every time I see an x, I'm going to replace it with x plus h, but don't forget the minus 5. So that's 3x plus 3h minus 5. That's f of x plus h. So now use the difference quotient. So that's f of x plus h minus f of x divided by h. So that's going to be, well, that's 3x plus 3h minus 5 minus, well, f of x is the original linear function. In this case, that's 3x minus 5 all over h. So what? I'm going to distribute the negative. Now, notice what ends up happening. The 3x's subtract out and the 5 subtract out. So I'm left with 3h over h. Well, I can divide out the h, and that's 3. So, in other words, the average rate of change for this linear function is 3. In the next video, I will show you how to solve different types of functions using the difference quotient.